Okay. Empty set has according to this, empty set should have an upper bound. Okay. Then what should be the least upper bound? Minus infinity. Yes, I am correct. Is it a real number? We want a upper bound, least upper bound, they are all in R, set of real number. We want in R, we don't go to extended real line. When you do measure theory, you need extended real line. Now we are in R, not extended real line. So our least upper bound are all in R. Okay. So then Y is telling in minus infinity means every real number is a empty set is subset of singleton alpha. That means greatest lower bound is less than or equal to alpha for all alpha. That means what is the real number less than or equal to every number is no number. Minus infinity is not a real number. That's why I think why some theorem we assume that non-empty. Why we give importance to non-empty. Don't just say that it doesn't matter. Okay, infinity means something why ask the question. So like this teacher, nice teacher is there, don't leave him. Then he will explain. If you don't ask, we may not realize that you need that. So if you ask things, naturally, if not immediately, we will also discuss next day or after few days, we will come and answer. Okay, it's clear? Now, convergence is that's the same thing. Xn is a sequence in R. Again, this will not spend more time. For epsilon greater than 0, there exists a stage n here. There exists n of epsilon, a natural number, such that mod xn minus x is less than epsilon for all n greater than or equal to n of epsilon. That's why it is in the neighborhood. Whatever may be the neighborhood, this we call it in R, open interval x plus epsilon, comma x minus epsilon, epsilon positive, it is a neighborhood of x. So how many points may be outside? N greater than or equal to n naught mean all are inside. N less than or equal to n naught mean we do not know. It may be inside or outside. What is important is whenever n greater than or equal to that positive integer n of epsilon, then all the xn's belongs to this neighborhood. That's however small, the neighborhood may be still very small. we cannot write, it may be still very small. Still only finitely many members are allowed, except finitely many all are inside. Okay. Now we will use Cauchy sequence. I will give the outline. Otherwise we will have only all the 5 days only basic thing. Okay. Now what is given? Xn Cauchy sequence. In fact, motivation is simple. What is our aim? To find a where it converges. You have to find a x. If at all x we feel that it is a Cauchy sequence mean, hence for epsilon positive, there exists a positive integer, n set of natural numbers such that mod xn minus xn of epsilon is less than epsilon. For what n? For all n greater than or equal to n of epsilon. That means, see, it is almost the x is closer to xn of epsilon. That is fixed. For a given epsilon, there is a n of epsilon. After n greater than or equal to n naught, the difference between xn and the n x suffix n of epsilon is less than epsilon. It may be 0.00001. I mean some practical purpose, that much error is we can tolerate. Then we can take that as good as that is our result. Okay. That's why we need numerical analysis also. So that is, hence this implies minus epsilon less than xn minus xn of epsilon less than epsilon for all n. Now we can add both sides, that is xn of epsilon minus epsilon less than xn less than xn of epsilon plus epsilon. Then for all n, see that means what will happen, if epsilon tends to 0, the interval will shrink. See, x will be where, if it converges means x will be between xn of epsilon minus epsilon and xn of epsilon plus epsilon. X will be there only. That means what? X will be greater than or equal to x of n of epsilon minus epsilon, and the same time x will be less than or equal to x of n of epsilon plus epsilon. Keeping this in mind, we define this set. Now take or define. So what we can feel x should be, go from left side to where you have to find the point x. Either you can go from left to right or right to left. Suppose we are starting from left. So where x suffix set of all x suffix n of epsilon minus epsilon. This set is for each epsilon there is a stage n of epsilon. Then for every n there is xn. From there minus epsilon. This is a non-empty set. Okay. Now this set as an, what do you feel, which is an upper bound? In fact, this varies. Fix epsilon 1 positive. Then prove that, immediate, prove that xn of epsilon minus epsilon less than or equal to xn of epsilon 1 plus epsilon 1 for all epsilon positive. See here, for a given epsilon there is xn of epsilon. Here epsilon 1. For that also only one way, now don't write the second. Epsilon is arbitrary, fixed. Any epsilon, this is fixed. Then we will have this. That means this will be less than or equal to xn of epsilon 1 plus epsilon for every element. This is an element in S. So what is an upper bound for the set S? Upper bound for S is every element. What is an element in S mean? For an epsilon positive, x suffix n of epsilon minus epsilon. That is an element in S. For each epsilon there is x n of epsilon minus epsilon. Each element is less than or equal to, see, first will be this condition when this will be true, whenever n greater than or equal to n of epsilon. This will be true for all n greater than or equal to, at a time you fix one epsilon but arbitrary. Here you have fixed. Now we can take the, both we want. N should be greater than or equal to n of epsilon as well as n of epsilon 1 also, our usual way. Take the, we want that x n of epsilon minus epsilon less than some alpha. Also we have on xn is, this we have. See, this will be from here. This will be from here we got this. This inequality will be true whenever n greater than or equal to n of epsilon. This will be true whenever n greater than or equal to n of epsilon 1. So you choose here, at a time epsilon is fixed, epsilon 1 also fixed. Then we can take the maximum of n of epsilon and n of epsilon 1 or even sum. Then this inequality will be true. Hence, not only what is great, the important thing is for every epsilon, epsilon 1 is fixed but arbitrary. Whatever may be the epsilon, x n of epsilon plus epsilon is an upper bound for s. Okay. Now use that one to prove that it has an upper bound. Hence, by LUB axiom, the set S has a least upper bound, say x. X least upper bound means what? X is least upper bound. For any epsilon, it is one element of S. This will be less than or equal to because an upper bound. Okay? It is upper bound. Among the upper bound, it is least. What can you say about x n of epsilon plus epsilon? That is another upper bound. This is least. So least will be less than or equal to this. So hence we will get modulus of x n of epsilon minus x is less than or equal to epsilon. Similarly, sorry, you have this mod xn, already we have this mod xn minus xn of epsilon. Instead of epsilon we can write epsilon by 2 also. Then triangle inequality, mod xn less than epsilon, xn minus x. We will write this is now mod xn minus x less than or equal to xn minus xn of epsilon plus xn of epsilon minus x. This will be less than epsilon or epsilon by 2. This and this will be by the definition of Cauchy sequence. Hence that will, they only on outline, but I don't want to spend so much time. You please, these 5 days, at least today and tomorrow you try. If you have doubt, you are most welcome to come and discuss. I will explain. Okay? We are not using anything other than LUB axiom. In a natural way, x is sandwiched between x n of epsilon minus epsilon and x n of epsilon plus epsilon for every epsilon. That's why you take the x should be, we know idea where it should be. So that will give you a, normally what many different ways will prove. One way is every Cauchy sequence is bounded. Once is a bounded sequence, then what? Every bounded sequence in R has a subsequence which converges to an element. Again, for that you need a LUB axiom. Again, a Cauchy sequence has a subsequence which converges, then the original sequence itself converges. All these things you will have to use. Here we don't use anything, just only the definition of Cauchy sequence and LUB axiom. And LUB axiom we cannot avoid. Completeness axiom, even to prove other results like Bolzano-Esters theorem, other things. Okay. Using these now, you will better understand now R power n complete or L infinity. What is L infinity? All the bounded sequences, real velocity, complex also allowed, set up all bounded sequences. Then distance between x, y, supremum of x is one sequence xn, y another sequence yn, then distance between x, y, supremum of mod xn minus yn. When we can write supremum? If the seq set mod xn minus yn should have an upper bound. First you have to verify. We should not write supremum without knowing whether it has an upper bound or not. First verify that using bounded. Mod xn minus yn less than or equal to mod xn plus mod yn. Mod xn is bounded, less than or equal to alpha. Mod yn is bounded, less than or equal to some other beta. Hence mod xn minus yn less than or equal to some alpha plus beta. It has an upper bound, hence supremum exists and it is real number, not extended real number, because d of xy should be a real number. It should not be infinity. Okay? So those things we can use. In between, if you want to have some break, you can, the organizer can tell. I mean, if you want to come back afterwards, we can come back. Now or after some time? After a few minutes. Whenever you want, you please tell. Okay. Maybe whatever we discuss, I will ask some of you tomorrow. So, like f from close AB to close AB, continuous means it has a fixed point. That is trivial in the sense that nothing but intermediate value theorem. Nothing but continuous image of a connected set is connected. That is what, to prove intermediate value theorem, you need this. Continuous image of connected set is connected. School level also we used to use BSc, that time we will not tell connected all those things. Easy to tell intermediate value theorem, because that is we use for solving equations everywhere, finding the root. There is a one root, one negative, one positive, there is a root, all those things. Well, not, but essentially what we need is continuous image of a connected set is connected. But the same thing even from R to R2, K a non-empty, closed, bounded, not interval. In place of interval, what we should have? K a non-empty, closed interval A comma B, closed set, non-empty, closed, bounded, interval. In place of interval, R2, Rn what we will use? Yes, convex. See, any 2 point can be joined. Set of all 1 minus t time x plus t time y, 0 less than or equal to t less than or equal to 1, that is nothing but line joining x and y, even in vector space we call it. So that we can define in any vector space. Thus later we will give example, simple example is every convex set in any non-linear space or Rn is pathwise connected and hence connected. Okay? But if it is a K non-empty, closed, bounded, convex set, f from K to K, continuous, yes, then the Rx is x in K such that fx equal to x. This is highly non-trivial. That's a morning also. It was proved by Prover in 1910, I think, yeah, 1910 or 12, 1910 I think. If it is a unit ball R power n, set of all x such that norm x less than or equal to 1, that is our K. F continuous function from K to K, then it has a fixed point. There you need algebraic topology or combinatoric or advanced calculus, I mean non-trivial proof. So there are even very recently also some people have given some different proof. Giving any something interesting proof will be known result but somewhat simple. It will be always, it is not easy. That is topological idea, algebraic topology or other ideas. Okay, that, but at least we should know the statement. K, not only that, later somewhere in 1930, Sauder, Sir Manning mentioned about Sauder. If K is a non-empty, closed, bounded in Rn is compact. Infinite dimensional case, closed and bounded set need not be compact. So we need compact. K a non-empty, compact, convex subset of a Banach space. Okay, Banach space means every Cauchy sequence in X converges to an element in that space. It is complete. complete metric space. Norm-linear space, which is as a metric space, d of xy equal to norm of x minus y, is a complete metric space. Okay. Then these are non-trivial again, but use Prover's theorem to prove Sauder fixed point theorem. K is a compact convex set, f from k to k, always compact or non-empty. Otherwise, to define a function, domain should be non-empty. Then it has a fixed point. Again, that is highly non-trivial. I mean, so using Sauder, at least we can understand. Prover is still more involved, and later we will see. Either you can use Prover fixed point theorem, or later what is called each image of each point is a set. See, suppose I am defining closed 0 open infinity. F I will call it T, just image of x equal to closed interval 0 comma s. That means what? What is T of half? Closed interval 0 to half. T of 1 is like that. Image of each point is a non-empty set. That's what morning Professor Berende also mentioned. K is a compact convex set. T from K to K multi-valued map. So there what is called upper semi-continuous, later will come. Inverse image of closed set is closed. That is called upper semi-continuous. Then that case, there exists a point x in K, so that x, not x equal to Tx, x belongs to Tx. Then we can use that theorem to prove what is called Nash equilibrium point. That is one of the lecture I am planning to give the proof, motivation to what is the importance of multivalued fixed point theorem. We will not prove Kakutani fixed point theorem or this, at least without anything. What is the natural way to get an equilibrium point? That was introduced by John Nash somewhere in 51 or 50, yeah, somewhere in, that's what the man, there was a beautiful Mind movie in English. He was a student like you, 21 years or so. That time he introduced, pardon?
I think it's 52.
Maybe 50, around 51, 52 in that period. So he introduced that concept, that's what I told, 2 pages. Later he, somewhere late 90s, somewhere in later, he received Nobel Prize. This was one of the important results, his major contribution, that is application of fixed point theorem. So like that many interesting applications are there. Of course all of us familiar with integral equation, differential equation, there are something called invariance of space problem and many eigenvalue, eigenvector, many things. So I will at least discuss this equilibrium point. Okay? Okay, we will have T, 15 minutes, okay, fine, that is good for, we are right from morning 9 o'clock today.